This is the myofibril. It is the location where the thick and thin filaments slide to cause a muscle contraction. In this case, the thick filaments are the dark purple structures that are called actin. The thin filaments, which are orange, are myosin. The zigzag lines are called the Z-disc, and this is where the actin connects to one another. And the next region over is called the H-zone. This is where thick filaments can be found. Then there's another Z-disc, and the pattern continues. In the H-zone, there is also the M-line. This is represented by the green line of Plato. Down below, we have what is called the I-band, and this is the region where only the thin filaments can be found. And then there's the A-band, and this covers the length of the thick filaments. Then there's the sarcomere. This is the contractile unit that runs from Z-disc to Z-disc. This is phase 1, or the excitation phase. In step 1 of phase 1, an actual potential arrives at a neuromuscular junction. Acetylcholine, which is a neurotransmitter, gets released from the synapses that are from the axon terminal and binds to the receptors that are attached to the sarcolemma. When acetylcholine gets released and binds to receptors on the sarcolemma, it causes a dipole or excited impulse. This impulse travels down through the T-tubes to the sarcoplasmic reticulum. In turn, the sarcoplasmic reticulum releases calcium into the sarcoplasm. It causes calcium to bind to what's called troponin. This causes a shift in tropomyosin that is blocking the active sites and reveals them. Now we are in what's called phase 2. In step 1 of phase 2, myosin head binds to the active site. Step 2 of phase 2 causes a release of ADP plus P, which causes a power stroke on the myosin head. The power stroke gets pulled up to the M line that we mentioned earlier in the myofibril. Therefore, nothing is bounded. Now we are in step 3 of phase 2. In step 3, a new ATP is binded, therefore causing myosin to get released. This leads us to our last step of phase 2. In the last step of phase 2, it breaks down ATP into ADP plus P and resets. This cycle continues until all calcium gets absorbed, which then stops phase 1 and phase 2. Remember, all muscles need calcium in ATP. If we don't have calcium in ATP, the cycle cannot continue.